Let's discuss something very interesting, and I'm going to discuss a concept called as surds. But for understanding what is a surd, first we need to understand an expression. So I'm going to give you an expression, observe this. Now the question is, how do you read this? You will say there is n, there is a symbol there, there's some sign there, and within that sign there is an alphabet written, a variable written, that is a. Now I'll tell you how do you read this. You read this expression as nth root of a. How do you read this? Nth root of a. Okay. So based on what I just said, if I give you certain expressions like this, I want you to read it on the basis of how we read this. Okay. Let's see. So now how do you read this? So check, just compare with what we read just now, the above expression, and based on that try to read this. 3, then you have a symbol, then you have 5. How do you read this? There it was nth root. So here you will say here it is 3, so you will say it is third root. So on the basis of that you understood this much, right? There you read it as nth root of a. That means the number or the variable which you had within that sign. So here what do we have? 5. So that means you will say, you will read this as third root of 5, and let me tell you, you are correct, absolutely right. So that means it is third root of 5. Okay. So now you are excited to read the next one. Wait, let me tell you one thing. This third root of 5 can be also read as cube root of 5. That's another option. That's another way of reading the same thing. Okay. Next. Now you are excited to read the next one, so I want you to read the next one. So what it is there? You will say there is 2. That means it is second root of. Okay. Second root of what? You will say it is second root of 10. Absolutely right. Okay, you will say second root of 10. So since I said here cube root, yes, you would be ready with this. You will say this is nothing but this is called a square root of 10. Absolutely right, my dear kids. So at least we have understood how to read such an expression. So the expression which I said, nth root of a. But here, let's understand the elements which you have in this expression. Here this n which you see, this is actually called as the order. It is called as the order. Okay. And this symbol, this sign which you see, this is called as a radical sign. And this number which you see within that radical sign is actually called as a radicand. Okay. So now the elements of this expression, that is nth root of a, we understood. N is called as the order, that symbol is called as a radical sign, and within that symbol what you have written is called as a radicand. So is this much clear? Now you are happy. Now you know how to read it. Now you know the elements, what are the terms used. Beautiful. Now you are ready to understand what is a surd. Okay, now let's understand, let's discuss. So any expression of this form, that is nth root of a, can be called as a surd only if it satisfies 3 conditions, my dear kids. 3 conditions. Condition number 1 is n, that is the order, is a natural number greater than 1. That means that order has to be a natural number greater than 1. Second condition is the radicand, that is a, the radicand a has to be a positive rational number. It has to be a rational number greater than 1, but it has to be positive. It has to be a positive rational number greater than 1. That means it can never be negative. Okay. Next, the third and the most important condition is nth root of a. That means the entire expression that is given to you has to be an irrational number. So when I say it has to be irrational, now we know which numbers are irrational. Any number when you write in the decimal form, and if it is non-terminating and non-recurring, if the decimal form is non-terminating and non-recurring, we say that it is an irrational number. So any expression of the form nth root of a will be called as a surd if it satisfies the 3 conditions. Let's revise. What is that? The first condition, n, that is the order, has to be a natural number greater than 1. Then the second condition is about the radicand, that is the radicand a has to be a positive rational number greater than 1, right? And the third and the final condition is that the entire expression, that is nth root of a, has to be an irrational number. If all these three conditions are satisfied, then we can say that given expression nth root of a will be called as a surd. Right? And that n, which we say order, that's called as the order of that surd. Right? And that is what we have discussed, that is what we have understood. So now you know. So let's check whether you can identify which one is a surd and which one is not a surd. Let me give you a few examples now. Observe. Okay, so we have here a few things written, right? Few expressions. So when you look at the first expression which I have written there, that is root 2. What is n there? Let's take all the three conditions. N, nothing is given, that means remember it is 2, right? So it is, the order is 2 and you know it is a natural number greater than 1. That means you will say first condition, done, tick. Second condition, it says it has to be a, that we are talking about the radicand there. What is the radicand there? The radicand here is nothing but 2. That 2, it's a positive rational number greater than 1. Yes, that means the second condition is satisfied. The third condition, nth root of a, that means the entire expression. What is the entire expression? That is square root of 2. It has to be irrational. It is irrational, right? Because when you find the square root of 2, you will see that you will get it as 1.41 and so on. It is non-terminating and it is non-recurring. That means we know all the three conditions are satisfied. That means we know the first one which I have given you, that is square root of 2, is a surd. Beautiful, my dear kid. So was that easy? You will say, wow, that's interesting. Now we know. Let's get on to the next one. What is that? Square root of 4. Because what is the order there? Nothing given, that means it is 2. We know the first condition satisfied. It's a natural number greater than 1. The order there, right? Now look at the radicand. Look at the radicand. Radicand is 4. It's a positive rational number greater than 1. Second condition satisfied. Superb. Look at the last condition. Square root of 4. That means the entire expression which is given. Now when you say square root of 4, you will say square root of 4 is 2. Isn't it? Square root of 4 is 2. Now 2 we know is the rational number. That means the third condition not satisfied. That means this expression which is given to you, that is square root of 4, is not a surd. That is great, isn't it? Yes. Superb. So now you are getting a grip on this concept. You saw the first one is a surd, the second one is not a surd. Let's look at the third one. What is the order there? The order is 3. It is a natural number greater than 1. What is the radicand there? The radicand is 8. It is a positive rational number greater than 1. The entire expression, cube root of 8. Cube root of 8, when you find, it is nothing but 2, which is again a rational number. That means again you will say the third condition not satisfied. That means that given expression is not a surd. Superb. Let's go on to the next one. Square root of 11. Now you should be fast at it. You should know by the look of it. You will say the first condition satisfied, that is the order. It's a natural number greater than 1. The second condition, the radicand there. The radicand, yes, it is a positive rational number greater than 1. Yes, that's satisfied. The last condition, look at the entire expression, that is square root of 11. Now square root of 11 is irrational, my dear kids. When you find the square root, it will be 3 point and will go on. It is non-recurring and non-terminating. That means we know all the three conditions satisfied. It is a surd. Beautiful. Let's go on to the next one. It is root of 20. Right, we know here what is the order. The order is 2. That's a natural number greater than 1. First condition satisfied. Second condition, talking about the radicand. The radicand here, that is 20. It's a rational number greater than 1. Right, beautiful. And the last one, the entire expression. That is, we are talking about square root of 20. So when we find out square root of 20, you will see that it is 4 point something. Again, it is non-terminating, non-recurring. That means this is a surd. All three conditions satisfied. Superb. Let's go on to the last one example which we have. Right? That is cube root of 20. What is the order there? The order is 3. So that's a natural number greater than 1. Look at the radicand. The radicand is 20. That's a positive rational number greater than 1. Look at the entire expression. The entire expression, that is cube root of 20. Now when you look at cube root of 20, that cube root of 20, my dear kids, when you find that cube root, right? Remember that. It is going to be 2 point something. It is non-terminating, non-recurring. That means again we know all three conditions satisfied. That means that last example, cube root of 20 is also a surd. So now we have understood what is a surd and what is not a surd. Wasn't that interesting? Let me give you a few more examples. So you're going to identify, state whether the following are surds or not. Let me list all those for you. So it's going to be very easy. Now, three conditions we know. Let's look at the first one. What is that? What is the order there? The order is not given, that means it is 2. So that's a natural number greater than 1. The radicand is 3, that's a rational number, positive rational number greater than 1. The entire thing, the entire expression, square root of 3 is nothing but it is irrational. Yes. So that means we know the first one is a surd. Second example, cube root of 25. The order there, that is 3. It's a natural number greater than 1. The radicand 25 is a positive rational number greater than 1. Entire expression, that is cube root of 25. It is irrational, right? That means the third condition is also satisfied. That means we know it is a surd. Look at the next one. It is cube root of 64. The order here is 3. That is a natural number greater than 1. Second condition, we know radicand is 64. That's a positive rational number greater than 1. And the entire expression, when you find the cube root of 64, we know cube root of 64 is nothing but 4. That is rational. That means the third condition not satisfied. That means the third example here is not a surd. Isn't that easy? Let's see this 3 more. What is that? Cube root of 10. The order there is a natural number greater than 1. The radicand here 10, we know it is nothing but it is a positive rational number greater than 1. And the entire expression cube root of 10, when we get, it is nothing but it is going to be an irrational number. That means it is a surd. Isn't that easy? Let's look at the next one. Right, what is that? It is square root of 30. That means what's the order? The order here is nothing but it is 2. That's a natural number greater than 1. The radicand here is 30. Yes, that's a positive rational number greater than 1. And the entire expression, that is square root of 30, when you find it is going to be 5 point something, right? It is going to be non-terminating, non-recurring. That means it is irrational. All three conditions satisfied. That means it is a surd. Going on to the last one, you will say that's so easy. You know the order here, that is 3. It's a natural number greater than 1. The radicand here, that is 8. What is that? It is a positive rational number greater than 1. And the entire expression, that is cube root of 8, when you find, we know the answer there is 2, which is rational. That means the third condition is not satisfied. That means this last example is not a surd. So with this, we know all the three conditions to check whether a given expression in the form nth root of a is a surd or not. You understood this. So now I know if any expression is given of that form, you will be able to identify whether it is a surd or not. Easy, right?
And yes, please do not forget to like, share, subscribe, and press the bell icon